So in the next part, we'll discuss about this energy of a satellite. So energy of a satellite means we are going to find out what about the value of total energy of a satellite. So which is nothing but the sum of its kinetic energy plus potential energy. So total energy is a sum of its kinetic energy plus potential energy. And we know that if we are having a satellite of mass, let's say small letter m, and it is revolving around a planet of mass, let's say capital letter M, and its orbital radius is equal to, take it as nothing but r naught. So we can just write the equation for its kinetic energy. We know the equation for kinetic energy is nothing but half into m into v square. So in this situation we can take it as half into mass of satellite into orbital velocity of satellite, the whole square. So we can write this is equal to half into m into. In the first part we discussed about this orbital velocity, and we know the equation for orbital velocity is root of gm divided by r naught. So if you are putting this value over here, then instead of v naught square we can write it as capital letter gm divided by r naught. So then the equation becomes g into m divided by 2 r naught. So this is the equation for its kinetic energy. Now like that we can find out what about the value of its potential energy. So potential energy means nothing but the gravitational potential energy, and we know the equation for gravitational potential energy of two masses m1 m2 separated by distance r is minus of g m1 m2 by r. So in this situation we can write as minus of g into mass of that planet into mass of satellite divided by orbital velocity r naught. So this is the equation for its potential energy. Now we can write the equation for its total energy, which is sum of kinetic plus potential. Kinetic we got it as nothing but minus of g mm divided by 2 r naught, and potential we got it as nothing but g mm divided by r naught. So we'll get the value of total energy is equal to minus g mm divided by 2 r naught. So these are the equations for kinetic energy, the potential energy, and the value of total energy. Now if you are comparing their magnitude, you can observe that the magnitude of total energy and the magnitude of kinetic energy both are same. I am just talking about their magnitude without a negative sign. So both are in magnitude wise both are g mm by 2 r naught, and total is negative and kinetic is positive. And which we can take it as something but half of the magnitude of potential energy, because potential energy is minus gmm by r naught. So half of that will get the value of total energy or kinetic energy. Now just try to understand what this negative sign indicates. That in total energy this negative sign indicates the boundness of that satellite with the planet. That means this planet, the satellite is under the gravitational influence of planet. It cannot escape from the gravitational pull of that planet. So in some situation they'll ask to find out what is a condition for a satellite to escape from the gravitational pull of this planet. Then the condition is that this total energy should be positive or it should be 0. So minimum it should be 0, and or it should be a positive value. So we'll say that it will be able to escape if total energy is greater than or equal to 0. So just try to understand once again what do you mean by negative. This negative sign indicates the boundness of this planet or with the satellite. So satellite cannot escape the gravitational pull of that planet. So remember this, the negative sign indicates that the satellite is under the influence of gravitational force exerted by the planet, or it is bounded with the planet if total energy of an object is greater than or equal to 0, then it will be able to escape from the gravitational influence.